Yes, dear students, in this video I will be telling you a very important term which is called radius of gyration. Here is the word radius of gyration. Radius of gyration. Gyrate means rotate. Gyrate means to rotate. So radial gyration of rotating body. Actually this term is used in rotatory motion very frequently and will help you to understand so many things easily. So I have written here already just to minimize the time and to explain the term. The radius of gyration of a body about an axis of rotation. When body always rotates about axis, you understand the meaning of axis? Your cycle wheel rotates around the axle fitted at center. So that imaginary line passing through that axle is axis rotation. Your cycle wheel rotates about the axle at center of circle wheel. If we think a line along that axle around which wheel rotates, that is called axis rotation. So radius of gyration of a body about an axis of rotation is the radial distance of a point from axis of rotation at which, if whole mass supposed to be concentrated, comma, its moment of inertia would be the same as with actual mass distribution. So it is known by k, small k. I have seen students don't write small k properly. Small k, please follow me what I say. Otherwise, our system becomes very ridiculous when we write wrong alphabets. Nowadays, students don't take care of alphabet formation. So, if m is the mass of body and k is the radius gyration, then its moment of inertia about the acceleration is equal to mk square. Now, because we have assumed point where whole mass is supposed to be concentrated, you have learned just now the center of mass. So this point is not center of mass. This point is not center of mass. It is imaginary point where we can assume the whole mass of body concentrated. For example, you can think of, suppose it is a disk. It is a disk of mass m and radius r. Its radius is r. Now the whole mass I am supposed to consider here. This whole mass instead of actual mass distribution. Then this is k here. Or moment of inertia in terms of the radial gyration I equal to mk square. I will tell you here moment of inertia of disk about this axis passing to center. That is in fact equal to half mr square. It is half mr square. So actual mass distribution, the whole mass distributed here. But we have assumed at this point. Then mk square is equal to half mr square. That way I am cancelling to k square equal to r square by 2. It means k is equal to r upon root 2. You know 1 upon root 2, how to solve it? it is root 2 upon 2, root 2 1.414 upon 2, it is 0.707. So it is less than k by r. So k here is equal to come out to be 0.707 r. Actually, moment of inertia of any body will depend upon the mass distribution, shape and size of the body, and it has radial distance of point where we suppose whole mass to be concentrated, and the moment of inertia of the body about that axis rotation is the same as with actual mass distribution. I mean, it is by k. So in case of disk it is this. In case of ring, just I told you in previous video, I is equal to mr square or I is equal to m. So k is equal to r. For ring, when body rotates about an axis passing through center normal to plane, so k is equal to r. I mean, so this is some definition of moment of radius of gyration. Radiation of, it is gyration, not gyration. Not gyration hai pronunciation. My colleague was insisting me, sir, it is gyration. I said no, it is gyration. I show him, I make him listen the pronunciation from dictionary as well as from Google, but she was adamant. Sir, I will call gyration. No, it is gyration, not gyration. Gyrate means to rotate. Now, there are two important theorems in your syllabus regarding moment of inertia. There are two important theorems regarding moment of inertia. Number one is theorem of perpendicular axis. Plural है axis है. Similarly axis, plurally axis, perpendicular axis. Here it is a plane lamina. This book behaves like a plane lamina. You can rotate like this. So this is one axis rotation about which the book is rotating. And please don't hesitate to understand. We can rotate this axis, maybe here also, maybe, but lie in the plane of the book. It may be rotated like this. This is another axis. This also lie in the plane of lamina. So this one, they will certainly intersect. And if we rotate about an axis passing through intersection, so that is another axis. So three axes are there. So what is the statement of this theorem? नहीं, ये मुश्किल से याद होता है, एप्लीकेबल है, बहुत सिंपल करता है बातों को. Theorem of perpendicular axis. Suppose it is any lamina. देखो शेप में भी irregular but mass distribution same, तभी lamina होगा. Here it is one axis, this is other axis, x axis like this. This is y axis. Here again 90 है, and this is z axis. So how to state theorem of perpendicular axes, x, y, z axis? So I state like this: the sum of movement of inertia of a plane lamina about the sum of moment of inertia of plane lamina about to mutually perpendicular axes lying in the plane of lamina is equal to the moment of inertia of same lamina about an axis normal to plane of lamina and passing through two mutually perpendicular axes lying in the plane of lamina. भाई थोड़ा नीचे गड़बड़ हो गया, मैं मिटाने जा रहा था, मैं ऊपर लिखता हूँ थोड़ा सा ना। ये लाइन लास्ट लाइन का है, टू म्यूचुअली परपेंडिकुलर एक्सीस लाइन इन द plane of lamina. This is very important theorem. In every exam, competitive exam, the question comes on the, we can prove it, but I will not prove here because proof is not worth mentioned here. So what I said, if some moment of inertia of lamina about two mutually perpendicular axes lying in the plane of lamina is equal to moment of inertia of the same lamina about an axis passing through the point of intersection of two axes and normal to plane of lamina. If in figure x and y axes are lying in plane of lamina and z axis normal to plane of lamina, then Iz is equal to Ix plus Iy. I will give you questions here based on this. Some students are requesting me to make a list topic wise and give separate lectures. Actually, these all are my lectures. You can see the playlist I have prepared chapter wise. In that playlist you can search. For example, this system particle and rotatory motion के नाम से ये हेडिंग है. इसके अंदर बहुत सारी प्लेलिस्ट हैं, उसमें आप इजीली ढूंढ सकते हैं. and the numericals are given in between, just to understand what we have learned, so that we really understand or not. That is assured by doing solution, by finding solution of problems. So this is the actually I show you again. I am telling you, okay, suppose it is any lamina here, you can rotate it like this. So this is the axis rotation here, lying in the plane of lamina. You can rotate about this. एंड थर्ड, अगर यहाँ पर ये एक्सिस है, ये इसका पॉइंट नहीं है, इसके अराउंड घुमाएंगे तो यू विल फाइंड, यू कैन रोटेट योर नोटबुक, यू विल फाइंड रोटेट अबाउट दिस जेड एक्सिस इज rather difficult than these two. Go to teach some of these two. So this is the theorem of perpendicular axis. इसका proof है, but no, you can read from the book. Now there is another theorem of parallel axis. Theorem of parallel axis. Don't ignore theorem of parallel axes. Parallel. एक होता है सेंट्रल मास. इस लैमिना का सपोज सेंट्रल मास यहाँ है और मैं इसके अराउंड घुमाता हूँ इसको यहाँ पर किस तरह से ऐसे, और एक यहाँ एक्सिस हो सकती है विच इज पैरेलल टू दिस, है ना. तो आई कैन रोटेट इट अबाउट दिस आल्सो लाइक दिस. तो मोमेंट ऑफ इनर्शिया अलग अलग होंगे और जरूरी कि नॉर्मली हो, passing through in the plane but passing central mass and other here. तो ये दो पैरेलल एक्सिस होंगे. तो how to show a diagram here? It is lamina here, this CM central mass and an axis passing through this. It can rotate about this axis. Let this be PQ. There is another axis, maybe here or away from this, RS. Distance between two axes be H. These axes may be normal to plane of lamina, may be lying in plane of lamina, but condition is that one axis passing through central mass. Here one axis passing through central mass. Other is parallel to it, maybe at any distance, maybe here also, maybe anywhere also, but parallel to the axis is passing through central mass. So what is the statement of this theorem? The moment of inertia of a plane lamina, lamina में तख्ती पट्टी, about any axis, about an axis, जैसे यहाँ RS, about an axis is equal to the sum of moment of inertia of lamina about an axis passing through its central mass and parallel to it. Sum of moments of inertia of lamina about an axis passing through center of mass and parallel to the given axis, and sum and product of mass of lamina and square of distance between the two axes. I mean, this is a statement. The moment of inertia of plane lamina about any axis is equal to sum of moment of inertia of lamina about axis passing center of mass and product of mass and square of distance between the two axes. So if in figure, I am writing here, if in figure PQ RS be any axis of rotation and PQ is another axis parallel to RS and passes through center of mass, passes through center of mass of lamina. Then IRS about RS is equal to ICM plus MH square, where what is H? We mention here H, distance between two parallel axes. I think you have got it very well. Video has become lengthy. We will apply here to tell moment of inertia of any lamina about different axes. Thank you.